Okay, this problem states a cannonball is fired at a 30-degree angle with the horizontal. It has an initial velocity of 50 meters per second. What is its range? So the first thing I'm going to do is I'm going to draw a picture for what's going on. It's a pretty basic problem. Right, it's fired, it goes up, it comes down. We know that we have an initial velocity of 50 meters per second. And we know that this angle in here, that's the angle with the horizontal, which I'm drawing right there, is 30 degrees. Okay? Basically, approaching this problem, they want to know what's its range. They want to know how far does it go horizontally. So the next thing we do is we break it down into its x and its y components. X and y. Okay, you folks know SOHCAHTOA, so you could actually look up breaking this thing down into its components. If you want to be a little bit easier on yourself, you can just remember for the x side you're going to use cosine, and for the y side you're going to use sine. So if I figure out the initial velocity here on the x side is going to be 50 cosine of 30. I got my calculator, so 50 times cosine 30 gives me 43.3 for the x. And 50 times the sine of 30, which is what we're going to have in the y, times the sine 30, gives me 25. Okay, once again, if you don't know where that comes from, take a look at SOHCAHTOA again. You're taking this vector and you're breaking it down into its x component and its y component. That's all you're doing. All right, so there's our initial velocities. In the x direction, your acceleration is always 0. In the y direction, your acceleration is going to be negative 9.8. All right, the x direction, we're looking for how far it goes, its range. So we want to know what delta x is. And we don't really have enough to do that just yet in the x direction, so let's keep working in the y direction. In the y direction, we know that its velocity at the top of its arc, halfway through its motion, the velocity at the top is going to be 0. So we can say final velocity is 0 meters per second. And this will allow us to figure out the time it takes to get halfway through its motion. So we can find a delta t here. Since I'm doing this on the video, I'm going to do all the math with you on the board because a lot of you guys are having trouble with the math. So hopefully seeing how we move stuff around in equations will help you out. All right, the equation I'm going to use to solve this y side, final velocity is initial velocity plus acceleration times time. So 0 equals 25 plus negative 9.8 times time. I would subtract 25 from each side. Negative 25 equals negative 9.8 times delta t. And then I divide both sides by negative 9.8. So if I do negative 25 divided by negative 9.8, I should get a positive answer of 2.55 seconds. So that's how much time it takes to get to the top here. If you wanted to figure out what its maximum height is, you could use the equation vf squared equals vi squared plus 2a delta y. Solve it for delta y, and that would give you the maximum height. But it doesn't ask us for it, so we're not going to worry about it. Now, keep in mind, that's the time it takes to get halfway through. So if we put that over here and we use it, we got to make sure that we multiply it by 2. Because we want the total range. It doesn't say, what's half of its range. Now it says, what's the total range? So we're going to have to double it. So when we use time over here, we're going to make that, what would that end up being? 5.10. Alright? Yeah, it looks right. Alright, cool. So 5.10. So now you've got everything you need in order to figure out what your delta x is going to be. The equation we'd use for this is delta x equals initial velocity times time plus 1/2 a times delta t squared. When you plug in, a is 0, so this whole side's going to go away. You'll be left with delta x equals 43.3 times 5.10. And 43.3 times 5.10, 43.3 times 5.10 is 220.8. 220.8 meters. So there's your answer. Alright? Things to keep in mind, if you can remember, the x side is going to use the cosine, the y side is going to use the sine, you're fine. Down here, acceleration being 0 on the x side is always going to make your life easier. It's always going to come down to this delta x equals initial velocity times time. Alright? So there's an example with the math 2D motion problem.